Okay, so thank you, Alpesh, and welcome to the attendees who are here right now to this session on SQL 2012 Always-On Availability Groups for SharePoint 2010 and SharePoint 2013. My name is Michael Knoll, and I work for a Bay Area company in the United States called Convergent Computing. We're a Microsoft Gold partner, and we do a lot of work within the SharePoint infrastructure space. I'm the author of several books on SharePoint as well and on other technologies as well. The most recent and pertinent to this discussion would be SharePoint 2010 Unleashed. We're also working on a version of that book for SharePoint 2013. So we will have SharePoint 2013 Unleashed as well. In my work at CCO, at Convergent, I do a lot of travel to speak at different conferences worldwide. In fact, currently right now I'm presenting this session from the other SharePoint Saturday event here in Melbourne, Australia, where I actually led a session this morning, Australia time. It's actually the same exact session. So I'm leading the session again for SBS India. Obviously it's useful when it's online because I can do two SharePoint Saturday events in the same day. But in any case, yeah. Sorry. Go ahead, Alfred.
Actually, I don't see anything on the screen now. Something's happened and everything's disappeared.
Let me see. It says continents of the world. In fact, recently we had a SharePoint event in Antarctica that I spoke at. So I do a lot of travel, including I did a trip to India to speak at several events across India in Pune, Chennai, and Bangalore a couple of years ago. And then returned for a SharePoint Saturday event in Sri Lanka a little bit after that. So definitely an area of the country or of the world that I'm interested in. Definitely enjoy India and hope you guys can get some useful information from this session. So what the session is about is it's about a new technology built into the latest version of SQL Server and how you can use this technology for SharePoint. So this version is SQL Server 2012, and it has a technology built in called Always-On Availability Groups. Always-On Availability Groups is a combination of both clustering and mirroring technologies together to allow you to have design options for SharePoint that you wouldn't have been able to have in the past. So for example, it allows you to create multiple copies of all of your SharePoint databases. So you can have copies of your content databases in different locations on multiple servers, and whenever there are changes made to those databases, they're automatically replicated to all of those copies of those databases. So it's a great concept, and it's something that we've put in place at many clients recently. So it's something that I wanted to have some conversations about to get the knowledge out there about what is SQL Server 2012 Always On, and what is SQL Server 2012 Always-On Availability Groups. So we'll talk about that. We'll talk about why it makes sense to have Always-On Availability Groups for SharePoint. And then we'll go through some of the requirements and prerequisites that are involved with doing Always-On Availability Groups for SharePoint environment. I'll walk you through as well a step-by-step guide to implementing the Always-On Availability Groups. And then permitting, if we're able to at least stream something towards the end, I'll try to at least share my RDP session where I've actually got an environment set up where we'll actually turn off the power on a SQL Server node and watch it fail over to another node. And you'll see how SharePoint can fail over within approximately 10 seconds or so to the other node itself, which is really what the advantage of this technology is. Any luck, Alpesh, with that slide deck? Did it come yet? I saw it go out the outbox.
Yes, it has just come through. So, yeah, I'm just going to quickly, I'm just figuring it out whether it should, because I even accessed that on the slide share itself. So I'm thinking.
Oh, use the one that I just emailed to you because I actually added one additional slide to that one just about a half hour ago. Okay.
Yep, sure. What I'll do. Yeah.
And then if you can start it on slide 4, and then I'll just tell you when it's time to switch over slides. Okay?
Sure, not a problem. Just give me a second.
Thank you so much.
Yep, no worries. Sounds good.
All right. So SQL 2012 Always On is a concept. It's essentially a marketing concept that Microsoft came out with, where they took the two high availability products that were built into SQL Server and they gave them this name called Always On. Always On actually means two separate things, though. There's an Always On failover cluster instance, or an FCI, and a failover cluster instance is actually the traditional shared storage clustering model. So it's actually it's the same thing that you would have been used to if you set up a cluster in the past, where you have two or more nodes, and those nodes all share a common set of databases in a central location. So it's shared disk, it's usually SAN storage, or some other type of shared storage that's used. So always on failover cluster instances are still possible to do within SQL 2012. But the reasons for setting up your SharePoint environment on an FCI are actually less now because of this new technology called AlwaysOn Availability Groups. So AlwaysOn Availability Groups corresponds to the next version of SQL database mirroring. So it's really what used to be mirroring, and it's now instead, looks like you're able to share the session. Okay, I'll let you pull that slide deck up here. But basically, Always-On Availability Groups is, there we go, there's the slide deck. Excellent. So yeah, slide 4, and that's exactly where I am right now.
Okay,
so the Always-On,
Michael, I've also given you control. Do you think you can change it? Like, in the sense, are you able to change the slide?
Okay, I'll see if that's going to work here.
Yep.
Technology, I'm telling you. Let's see. Yeah. Okay, looks like I have some kind of control here.
Yep, it changed.
Oh, look at that. Okay, great. Okay, so a little bit about the background of this technology. The original concept was log shipping in SQL 2000. And with log shipping, you made a duplicate copy of your databases on another server. That concept got improved in SQL 2005, Service Pack 1, and it became a concept called database mirroring. So that created some improvements, such as allowing for synchronous support of databases. So you could create synchronous exact copies of your database on another server, but you still were limited in that you could only have a primary copy and a secondary copy. Always-on Availability Groups takes that mirroring concept and allows you to have up to 4 mirrored copies plus other capabilities, which we'll talk about here. And so the advantage that this gives you for SharePoint is that it gives you much better high availability options than you would have had previously. Okay, let's see that. Here we go. So just to kind of list out what these availability options are, if you start at the bottom of that list there, you'll see some of the more traditional high availability options that people have looked at, but you'll also note that those traditional solutions have the potential for having you lose a lot more data, and they have the potential for having your environment be down for a lot longer. So, for example, with backup, copy, and restore, which is kind of the traditional approach to high availability, you could lose hours worth of data, in some cases even potentially days worth of data, and the amount of time it would take to recover your environment could be days, because you'd have to restore the server, you'd have to recover from tape, etc. There's no capability for automatic failover, and you don't have the ability to do things such as readable secondaries. Log shipping's a little bit better. Database mirroring, you get from even better than that, where you can have only potentially seconds of lost data, and you might be able to be up within minutes, but you don't have those automatic failover capabilities, at least not with asynchronous mirroring. The FCI that I talked about, the shared storage clustering, which is still possible, does allow you to fail over, so you don't have any data loss. That's why it says NA there. But then at the same time, it may take you between seconds and minutes sometimes to fail all the disks over on an always-on failover cluster instance. At the same time, it also doesn't have the readable secondaries. So the best options are really the always-on availability group options. You've got both synchronous commit options and asynchronous commit options. In a perfect world, you would use synchronous commit, but that would be when you have very good connectivity between your servers. And when I say very good connectivity, I mean you have to have at least a gigabit of bandwidth plus less than 10 milliseconds of latency between those servers. And if you have that, then you can implement synchronous mirroring between those servers, which would allow you to have a data loss or what we call an RPO, a recovery point objective, of 0. So you would lose no data in an outage. And your recovery time actually is in the realm of seconds. In production environments where we set this up, we've actually timed it to about 5 to 7 seconds for failover between nodes. So it's almost fast enough where SharePoint itself as an application is not even aware of that there's a failover taking place at the data tier. You might be able to get it to have a few transactions time out, but for the most part, SharePoint almost doesn't notice the failover process itself. So these kind of options are the reasons why we architect new SharePoint environments with always-on availability groups. Now, why you would use asynchronous as opposed to synchronous generally comes down to the speed of your network traffic. So, for example, if you had a SQL server that was in India and another SQL server that was on the other side of the world, you wouldn't be able to do synchronous commit because the transactions would take too long to be written into both copies of the databases, and the transactions would just time out. So instead, you would need to use asynchronous commit options, which don't wait for the data to be written in on both sides before the transaction's committed. The downside to asynchronous, though, is you could potentially lose some data. So you could lose seconds worth of data in an outage. And it's also only supported for specific types of SharePoint content or SharePoint databases, which I'll talk about. Okay. Next slide. Here we go. In terms of design options now for with always-on availability groups, it allows you to create up to 4 additional copies. So that's a total of 5 copies of any database that you have within the always-on availability groups. At the same time, the copies can be a mix of both synchronous or asynchronous databases. And then, as I mentioned, just make sure that if you're using synchronous copies, you have to have at least a gigabit of bandwidth or latency less than 10 milliseconds. If you do not, your transactions are going to time out. Okay. Moving on. Another key feature for SharePoint, which is highly useful within SQL 2012 Always-On Availability Groups, is the concept of read-only farms. So read-only farms allows for you to be able to have a secondary copy of that content database in a different location and have that be set up for read-only access so that a SharePoint farm can actually connect to that read-only copy of the database and read the content that's within it. That's something that you couldn't do previously before SQL 2012. You couldn't do that with a mirrored copy, for example, because it didn't allow you to connect to the database while the mirror was in operation. In this case, it's allowed, which gives you the flexibility to have these read-only farms in remote locations where you want to bring the content closer to the end user itself. It does, of course, though, however, require you to have a separate SharePoint farm from the actual production read-write farm itself. All right, here is the key diagram that I want you to study because it actually illustrates multiple design options and kind of the best design options of what you can do with SQL 2012 for a SharePoint environment. So just to kind of introduce, what this all means here. If you look at the boxes there, the box on the left is the dark lined box, outlines a primary data center. You've got another one for another data center that's located very close to the primary data center, so it has very good connectivity. And then you have a remote office plus a disaster recovery data center, so 2 other separate locations that may be on the other side of the world. The databases themselves are broken up into 2 availability groups. There's one availability group for the SharePoint content databases, and then there's another availability group for the SharePoint service application databases. And the reason that we do that is because it's really only the content databases which are supported for asynchronous mirroring. So if you want to be able to asynchronously mirror your databases, you can only do that for the content databases, and there's actually only one other type of database, which is the secure store database, which is supported for asynchronous mirroring. The rest of the SharePoint databases, however, are supported for synchronous mirroring. So that's why we have another availability group which is used for the service application databases. And that's key to the flexibility with AlwaysOn Availability Groups, is this ability to create multiple availability groups on a single set of servers. And when I say single set of servers, however, all of these servers need to be part excuse me, of the same Windows Server failover cluster. And that Windows Server failover cluster is what ties together all of these servers themselves. So you'll see these 5 servers that I have here. They're all part of the same cluster, the Windows Server failover cluster. Now when I say cluster, this is a shared nothing cluster. It's not sharing anything. There's no shared disk that's part of it. The only thing that's really being shared is what they call the listener name. And that's the name that SharePoint connects to. So all of these SharePoint servers that are up here, they're connecting to a name. They think that their SQL server is just, let's say, called SQL, when in reality the names of these servers are SQL 1, SQL 2, SQL 3, SQL 4, and SQL 5. But that name is shared between all of those different servers within this individual cluster itself. But that's kind of the key to AlwaysOn Availability Groups, is this concept of having both clustering and mirroring tied into the same framework itself. So you see in this particular model, the advantage to this is within this primary data center at my data tier, I have the ability to fail over automatically between this first SQL server here and the second SQL server here. Automatically. So if one of these servers goes down, the other server automatically picks up and runs these content databases on that other machine. If I lose the entire primary data center, I can fail over everybody over to this other highly connected data center, because I have a synchronous copy of all of my databases. All of my content databases plus all of my service application databases are all on that highly connected data center. And I've got, of course, SharePoint farm servers that are member of the same farms. So I've got the web roles and the service application roles running on a third server here that allows me to fail over all content to that data center. Now, if I lose, let's say there's a disaster in the entire metropolitan area that takes out both the primary data center and the other highly connected data center. Like, let's say, you have a massive power outage, which I think that was in the news recently, but something like that. It takes out an entire area and it drops all your data centers there. You could bring up your content on one of these other remote offices or the disaster recovery data center by just having a farm on standby, or what we call a cold farm, that then can connect to the copies of these databases. Now, because you just have your content databases, you won't have your service applications, which will affect functionality. And you may decide, for example, to just turn on your farm into read-only mode so that you can actually just access the content. And then once the power outage is recovered in the primary data center, you turn that back on and allow it to be read-write in that case. Or it may be that it's a large enough disaster, like let's say a major earthquake, where the data center is going to be down for a long period of time, in which case you can then fail over more or less permanently to one of these locations. You just will have to recover your service application databases. So again, this diagram really gives you an idea of how you can take advantage of AlwaysOn Availability Groups to create these multiple copies of your databases in multiple locations. Okay, moving on. So what this really does is this completely changes the design options for the data tier. We didn't used to have this kind of flexibility before. It allows us to have something similar to what's provided with an Exchange server, which now Exchange 2010 has this concept of what they call database availability groups that allow you to take your Exchange databases and have up to 16 copies of these databases in different locations. Well, we can't do 16 copies, but at least we can do 5 copies total of all these different databases. and allows you to really improve the flexibility of your design options. It's also at the same time the equivalent of a constant backup running on all of your databases. You have multiple copies of your databases, which means that if you lose these disk storage on one server, the other server will automatically be able to run the databases on that other machine because it has an exact copy of everything and every transaction that was ever put into that first database. So it really improves over a traditional cluster, which you have to back up on a regular basis. At the same time, then it's can be used to create those disaster recovery copies of your SharePoint databases. And one thing I will note about this, if you're used to SharePoint 2010 in a mirror configuration, and you'll note within SharePoint it says what's the mirrored copy of my databases, you actually don't even need to configure that anymore with SQL 2012 because SharePoint itself no longer needs to be aware of the mirrored copy. In fact, it won't even fail over unless you configure it manually within SharePoint Central Admin. What that effectively means is SharePoint just connects to that name. It connects to the name SQL, and that name is shared between all of the different nodes. At the same time, SharePoint 2010 supports SQL 2012 fully. Of course, you have to be running Service Pack 1 to get that support. So if you're not running Service Pack 1, make sure you upgrade to Service Pack 1 before installing your databases on SQL Server 2012. And do note the caveat down there, the warning, is that make sure you have good connectivity between synchronous copies or else your transactions are going to time out. If you need to set it up for slower WAN links, use the asynchronous database or the asynchronous always-on availability group options. There we go. The biggest downside to using SQL 2012 always-on availability groups is the licensing requirements of the technology. It does require Windows Server Enterprise Edition as well as SQL Server Enterprise Edition. So, of course, basically cost becomes a major factor in deploying SQL Server 2012 always-on availability groups because they're only allowed in the Enterprise Edition of SQL Server. Now, that said, usually what my clients do is they start some negotiation process with Microsoft where they can get a better deal on some of the equipment, or they could take existing licenses of SQL Server and translate them over to SQL 2012 licenses, a concept we call grandfathering in different licenses. But basically, talk to Microsoft when it comes down to it, and do take note of factors such as the fact that if your second SQL Server is used only for failover, generally Microsoft doesn't charge you a license for that second server. You only pay for the first one. But in terms of Microsoft has moved away from the per-socket licensing model that they used to have with SQL Server, and they've now moved into a per-core model, where the licenses cost they're about a quarter of the cost of what they used to cost, but you need a lot more licenses than you would have needed in the past. So if you have a SQL Server that was a dual-core server, you actually come out ahead because you're only paying 50% of what you would have paid with SQL 2008. If it's a quad-core server, you're paying about the same. But if it's a 6-core server, an 8-core, or multiple cores beyond 4, unfortunately you end up paying more, which is why it's useful to reuse some of your old licenses if possible. So again, that's really the only big downside to SQL 2012's always-on availability groups is it's not necessarily going to be affordable for everybody. All right. From a Windows OS perspective, there's a couple of prerequisites and requirements. One, do not install this on a domain controller. It's not supported. You need to make sure you're using Windows Server 2008 or 2008 R2. My preference is to use Windows Server 2008 R2 SP1, the latest version. It must be a node within the cluster. Until you add it into a Windows Server failover cluster, you won't actually be able to do set it up for always-on availability groups. And then make sure it contains sufficient nodes to support the configurations. And I've got a slide that will describe that in a little bit more detail. At the same time, you want to update your Windows servers that are running, that are going to be running SQL. You want to update them with all the latest security patches, as well as some additional patches which are required specifically for always-on availability groups. And I've listed those patches here, and I'll also give you a link at the end of the slide deck to be able to download those particular patches. Most of those patches you'll need, however, the last 3 patches in that list are generally not always needed, just because those patches are only for specific scenarios such as IPsec, IPv6, or a very specific scenario that applies to slow failover situations. So those are not generally going to apply to everybody. Okay, this part is a bit complex, so let me try to explain this part. But it is possible to use an FCI, which is again a traditional shared storage cluster, together with an always-on availability group at the same time. However, if you do that, the failover can only be configured within the FCI itself. You cannot failover between the databases which are controlled by the FCI and the databases that are on another always-on availability group node. So basically, what that means is, you could set up a scenario where you have, let's say, a 2-node traditional cluster that's using shared storage, and then you've also got always-on availability groups that's making a copy of those databases on another server. But you can't do automatic failover to that other server. You can only failover within the FCI itself. At the same time, it also requires a manual configuration of the always-on availability group. If you've modified the collation, just note that the collation must be the same for every server within it, which generally you wouldn't modify the collation on a SQL Server for SharePoint. And also note that if you're using the file stream provider, that all of the servers within that availability group need to be using the same file stream provider. That applies to RBS scenarios as well. So if you're using SQL RBS, you need to be able to have all of these servers configured for RBS as well. Okay, so from a cluster perspective, I mentioned that you need to have the proper number of nodes and the proper number of votes, depending on your situation. So I've outlined approximately 4 different scenarios here. And it's important to understand why you need to have these votes in place and on the way that clustering works. So let me try to dive into this. I'll use the simplest scenario here. Scenario 1, where you just have 2 database servers, and you want to configure them to automatically fail over between SQL 1 and SQL 2. To do that, you need to have a majority number of votes that decide which copy of the database is actually the primary copy of that database. So you'll actually need to add another server into the mix or use an existing file server that you can use as what's called the file share witness. And that file share witness allows you to be able to have a third vote that decides whether or not a server will become the active and primary copy. So let me give you a scenario about why this makes sense and why this is very important. Let's say in that scenario 1, SQL 1 is running actively. It's running an active primary copy of all those databases. SQL 2 is running a secondary copy of those databases. In the event that SQL 1 gets unplugged from the network, at that point, if SQL 2 were to automatically turn on, and then SQL 1 were to be connected back up to the network, and they were both running an active copy of the databases, you would have what we call a split brain scenario, where they're both active primary copies of those databases. So you want to avoid that, which is why what's built into the cluster service within Microsoft is the need to have a majority vote. And that majority vote means that I need to have 2 votes out of 3 total to be able to decide whether or not I'm going to turn on a database. So in that scenario where SQL 1 gets unplugged from the network, SQL 1 would notice that it can no longer talk to SQL 2. It would be sitting in the middle of a transaction, a synchronous transaction, and it would say, hey, I can't talk to SQL 2 anymore. It looks like there's an outage. And to the SQL server, it may look like it's an outage of SQL 2 itself. So it goes and it asks the file share witness to see, hey, can you vote together with me to determine whether I'm going to continue running or whether I should shut down. Now, if it's disconnected from the network, it won't be able to talk to that file share witness. So it will only be able to have one vote. Whereas on the network, SQL2 and the file share witness will get together, and they'll both vote to turn on the primary copy on SQL2. So SQL2 will turn itself on as the primary copy of the databases because it has 2 votes out of 3. Now, if you have 3 SQL servers, such as what's shown in scenario 3, you already have the 3 votes that you would need. So any 2 of those servers could act as a vote to determine which copy is set up for automatic failover. Scenarios 3 and 4 are scenarios where you either have 4 SQL servers or 5 SQL servers. And it's the same concept, except in those scenarios, we need to have 3 votes to determine who becomes the primary copy of those databases. So it's important to understand how the cluster service works. Otherwise, your failover won't take place properly. So if you just have 2 SQL servers that are configured for failover, it won't allow you to failover automatically between those 2 servers. You need to have that 3rd vote that's a part of that. And again, that's to avoid split brain scenarios where multiple primary copies of a database are running at any one time. Okay, so just the high-level steps that are associated with creating an always-on availability group. Step 1 is the creation of that Windows Server failover cluster. And that's done by adding the feature, the failover cluster feature on each node that you're setting up for this. And in my scenario, you'll note so I'm installing the failover cluster service on every single one of those, and I'm adding them together into a cluster. So I'm going to create a cluster, and in my case, if you look at that diagram, you'll see my cluster name is SQL2012.companyabc.com. That's not actually the name that SharePoint connects to. SharePoint's going to connect to a different name that's going to be a cluster resource name that we create. It's called the client access point or the listener. So we'll create that as part of a later step. But first thing I do, again, is create that cluster instance and configure the cluster appropriately, which means if it's just 2 nodes within a cluster, I need to add that additional vote. I need to add that file share witness on a 3rd server. If it's 5, I need to configure it appropriately. So that's the first step, is to actually create that WSFC. After step 1 is step 2, to prepare the nodes. That's to go through and install the .NET Services 3.5 feature on each one of the SQL nodes. Install SQL 2012 Enterprise Edition database services. And all you need is the database services component. You don't need any of the other installation components, so don't select reporting services or any of these other components. The one exception to that, of course, is the SQL management tools. I generally install those as well. Make sure your firewall ports are open, which for SQL means opening port 1433. And then from a service account perspective for SQL Server, ideally use the same service account for all nodes that are part of that cluster. Don't use network service, otherwise it won't work properly. And if you are using Kerberos for SharePoint, make sure that you have all of the SQL names listed as SPNs, or as service principal names that are associated with that service account. So that includes the names of the servers, in this case SQL 1, SQL 2, and SQL 3, but also the listener name or any names of the availability groups. So that would include, in my example, that's just SQL, but it could also be availability group 1, availability group 2, availability group 3, those types of things. Make sure your databases are set to full recovery mode, so don't have them in simple recovery mode or some other recovery mode. And ensure that the file paths and the drive letters are consistent, which means if your logs are on the D drive and your data is on the E drive, make sure that's the same across all of the servers. Otherwise, it's going to be a lot more difficult to configure the availability group. And then generally, you also need to, of course, copy or create the SharePoint databases on the primary node only. And if we can get into the demo environment, I'll show you that here. Also, before you can set up a database as a availability group, you need to make sure you perform a full backup of those SharePoint databases. Final note is to make sure you're creating a file share location that's accessible by all nodes that will be used for those backups. Okay, moving on to step 3. Step 3 is pretty simple. All you do is open up the configuration manager on the SQL servers, and you specify to enable AlwaysOn Availability Groups. So you'll note I have the cluster name that's there. I can check that box. If that box is grayed out, that means that you're not a member of a cluster. You have to be a member of a cluster first. Repeat that on each of the nodes, and then make sure you're restarting the SQL services on each one of those nodes. So then moving on to the next step, we create the availability group. Ideally, you would use the wizard. The wizard itself will automate the entire process for creating that availability group. It is the best tool for that particular process. But you'll note here in that screenshot I have SQL 1, SQL 2, and SQL 3 all added in as replicas. The SQL 1 replica is configured for automatic failover. It's configured for synchronous mirroring. SQL 2 is also configured for automatic and synchronous, but SQL 3 is asynchronous because I didn't check that box, and it's also configured as a readable secondary copy of the database. So it's the scenario where I want to have a read-only farm in a different location in this case. And then for creating the availability group, just to continue that particular step, make sure you have that shared network location set up for the backup files because it will request it when you're setting up that availability group. And then depending on the size of the databases, it could take a while to actually go through that process. However, you can pre-stage the backups. The scenarios where you would do that is a scenario where you have a very large database and you need to, let's say, ship a tape with a backup of those databases, ship it over to a remote location, and then restore it onto a server, and then do what they call a join only, which will do a delta synchronization of the changes between when that backup was made and the current copy of the databases themselves. It will go through and validate all the steps, which should show green for everything, except you'll note, of course, I have one yellow, which is for the listener because I haven't created the listener yet. You can create the listener as part of that process, but I'll create that as part of the next step. And the next step is then where we go through and create the listener. So that listener is what SharePoint is going to connect to. If you look at that screenshot where it says listener DNS name, we're pointing to SQL, even though, again, my SQL servers are SQL 1, SQL 2, and SQL 3. So we're pointing to an availability group name that is shared between multiple servers. And this is where I would also specify all of the IP addresses which are required for the different subnets that may exist within that cluster. So I would add, in this case, you'll see I added 10.10.10.59. I could also add another subnet in there that I would fail over to. And that way, if it needed to fail over to a copy in a remote location, I could use a different subnet as part of that. Of course, along with that, you need to make sure the TTL of that value, the time to live of that value, is around 60 seconds or less to make sure that you're not caching that name, that old IP address. The application isn't caching it. And the application in this case is, of course, SharePoint is the one that's connecting directly to this SQL server. Okay, next slide. Here we go. Okay, so this may or may not work. I'm going to try to at least demonstrate to you. I've got an environment up on my machine, and I'm going to need to try to share my screen. So I'm going to hope that I'm allowed to share here. So let me, if I can flip over to my screen, I'll try to do this, Alpesh.
Yep.
Okay. Releasing control to you. Let's try to share the screen. Have there any questions come up while I've been talking, Alpesh?
I'm not sure. I need to check. The reason being, I had basically I could not look into any of those screens. So. Okay.
No problem. It's fine. It's fine. I'm just wondering in the meantime.
No,
because,
I'm not seeing any questions.
Okay. All right. So I'm sharing the screen. Can you see my screen?
No, it's saying loading, so yep, there we go, something's up.
Excellent. Okay, let's give this a shot. I guess shout out to Debbie, by the way. I see she's now online. So hello, Debbie.
Yes, she is
Yeah.
online now.
Yes, yes. I'm somewhat close to Debbie now. Well, Melbourne. So. All right. So can you see the screen here?
Yes, we can.
Excellent. Okay. So hopefully this holds out here. But this is my SharePoint site. Let me try to actually unpin this toolbar because I need to. Yeah, there we go. I have just a blank SharePoint site that I created. It's running on a SharePoint server here. I have some content databases that are part of this. And let me minimize this. I'll just show you. I have SharePoint 1, which is my SharePoint server, and I have a SQL 1, SQL 2, and SQL 3. So let me go into SQL 1, which is the primary copy of the databases right now. On this server, I have an availability group that's set up. It's availability group 1. Within that availability group, it's set up for all 3 SQL servers here, and it's also set up for the databases which are a member of this particular farm. So again, a very simple configuration. In a major production environment, I'd actually generally have 2 availability groups, one set up for the content databases and one set up for the service application databases. But in this case, what I want to show you here is I'm actually going to kill the power on this SQL server, and we're going to watch it fail over to the other node here. So let's do that very quickly here. SQL 1, which is the server that SharePoint is connected to, I'm going to just turn it off. So here we go. And then I'm going to quickly switch over to the SharePoint server because hopefully within about the 10 seconds or so that it's going to fail over, I should be able to demonstrate to you that it will come back online. We may get a few error messages while some of the transactions time out, but usually it goes over fairly quickly. So let's turn off this server. I'll hit turn off. Okay, go back to the SharePoint server, and I'm going to try to refresh these pages and see what we come up with here. So right now, SharePoint is confused. It's trying to connect to the name SQL, but SQL hasn't failed over yet. So I had one transaction that's timed out. I'll get messages like forbidden, but within about 10 seconds, yes, now if you note at the bottom, there we go. It's connected back up. So that was even maybe a little bit faster than 10 seconds. We are now connected to the databases, which are located on, let me just refresh that. There we go. The databases which are located on SQL 2. So if I minimize this and I go into SQL 2, I can show you here that it'll show that, let me refresh the availability group. I'm now the primary copy on that availability group, and SQL 1 I can see is down. So SQL 1 is down, but the databases have all failed over to SQL 2. So again, within our production environments where we set this up, this is about 5 to 7 seconds on the failover itself. All right, I want to show you the creation of a new availability group. So I'm going to actually turn SQL 1 back on, okay? And then we will, I'll go through and create a new database here that's part of this process so I can create a new availability group. So let's go into the SharePoint server. Let's just add another content database just so that we can create a new one. And we'll call this one, love those goods, call it SBS India. Note my database name is SQL. That's the name of the listener that I'm choosing to connect to. And we'll click OK here. Notice I'm not also filling in the failover database server. That's for a reason, because SharePoint doesn't need to know this. It's completely out of SharePoint's control at this point. We don't need to configure that. So let me click OK there, and it's going to create a database. But of course, since SQL 2 is the active copy, it's going to create that database on SQL 2. So while it creates this database, let's flip over to SQL 2 here. And we should see that new database show up if I refresh this page here. Let me refresh this. And yeah, so there's the database here. Now you'll note, though, there's no green arrow next to it, which means that it's not part of an availability group. I need to actually add it to an availability group. So the only reason I did this is I wanted to create an availability group from scratch without destroying my other ones. So you'll see this morning in Melbourne, I created one already here. So let me just delete this one here, and I'll create a new one just for this presentation, just to kind of show you the process that you go through to create that. Okay, so that's deleted. Let's, I think actually this should show SQL 1 coming back up soon. It's not up yet. The first step that you have to do incidentally is you have to also back up this database. Microsoft requires you to back it up first before it's added into an availability group. So I ran a quick backup there, and now I can create that new availability group. So let's go through and create that, run through the wizard, show you how easy this is. So let's give this a name. And there's the, actually I could go let's add them both in, why not? Going crazy. Actually, no, I know it'll fail because it already has another copy, so I don't want to get too out of hand here. But so there's the India one. It meets the prerequisites. Let's add the other replicas in. So I'm going to add SQL 1 in as a replica. SQL 1's back online. I'm going to add SQL 3 in as a replica. SQL 3 is coming up here. I'm going to set these SQL 1 and SQL 2 to be synchronous copies and to automatically fail over between SQL 1 and SQL 2. And then I'm going to set that SQL 3 one to be a read-only copy. And so I'm going to set the readable secondary to yes. And if you're wondering, read intent only doesn't apply to SharePoint. It's actually something very specific to SQL 2012 that SharePoint doesn't support. So you want to set this to yes for readable secondaries. And I'll just click through the rest. Oh, actually, before I click through, sorry, note that you can configure all the endpoints here. You can configure the ports. It does this automatically. You can also specify what the backup preferences are, so you can have it back up a secondary copy of the databases as opposed to backing up a primary copy. And then I can also decide whether or not I want to create that listener. So in this case, let's create a listener. Let's call it SPS India. It'll actually create this DNS record for us. It's going to be port 1433, the standard SQL port, since we're using the default instance here. And I'm going to put in an IP address that's associated with this. So I can select from my subnets, and I can put in an IP address. So let's call this one 134, just for fun. Next. I'm going to use the listed endpoints. This is where you specify that shared location that's used for the backups. So we'll go through. And it should go through and create everything. Yes, everything's validated. Click Finish, and it'll go through and create that availability group and allow us to fail over those availability groups. Of course, at this point, I would have to go into SharePoint Central Admin, remove the database, and re-add it as being on a different SQL Server name. That different SQL Server name is SPS India, or the name of my listener. So that's the additional step I'd have to go through. And you should also note that every time you have a new database that gets created, you have to add it to an existing availability group. So if I went in and create that new database and I want to add it to my content availability group, I need to go in and do that either manually or via a script itself. So we have one error. Did I create SPS India already? Probably not. Oh, it might be the same IP address. Can't believe if I did that. I might have used 134 for something else. Anyway, if I didn't do that for the IP address, it would still come up. It's still here. It just needs to fix the IP address. But it actually looks like it created it. It's got to redo the listener. But in any case, you'll see the database is there. It's got primary on SQL 2, secondary on SQL 1. And I want to show you one last thing before I wrap up here, and that's the failover of manual failover process. So I'm going to manually fail over from SQL 1 or from SQL 2 back to SQL 1, which is something you may want to do when you're doing maintenance or those types of things. And I will connect to the server properly. And at this point, if I were to switch over to that SharePoint server, I may still get it to timeout. Sometimes it does timeout as well too, but it will fail over within about 10 seconds or so. The failover from a manual one is approximately the same amount of time as a disaster failover, which is interesting. So click refresh. I think that's almost got it. This one has it. This one has it. So it's back up. So that's basically the concept. You can see it's relatively straightforward to create these all very quickly. Let me just give you one more. I guess I can use my slide deck since you guys can still see here. So From a summary perspective, before I jump into some questions, make sure you, this changes everything in terms of the data tier designs for SharePoint. We're starting to do with some very big clients. A lot of clients of ours now, I'd say at least 80% of the ones that are setting up SharePoint for high availability are moving to using SQL 2012 AlwaysOn Availability Groups when it's a new environment that's being set up. It's supported by SharePoint. It's recommended. It works very well. It's easy to administer, and once you set it up, it just runs. So make sure you're following the guidelines closely. Follow everything that's been presented within here, and play around with it before you put it into production. But again, it is a very useful concept. So, with that said, I guess I may have one or two minutes here for questions. But if I don't get a chance to answer your question, I'd encourage you to contact me via Twitter. So you'll see my Twitter handle there, which is Michael T. Knoll. You can also download these slides on slideshare.net/Michael T. Knoll. And I would also encourage you to visit my travel blog, which actually has nothing to do with SharePoint. It's just something that kind of a hobby I do on the side. That's sharingtheglobe.com. I actually have a couple of blog posts on my trip to India that I did a few years back, where I was able to do. I went with Joel Olson and another guy, and we swam in the Ganges. We had a really good time while we were there. So, with that said, are there any questions, Alpesh?
Thank you, Michael. No, I'm not looking at any questions so far. But yeah, it's been great to have you, especially since you're traveling, and I don't know how you managed to do this, but it was good to have you. As always, you are there to present for SPS India. So thank you so much, and I'm sure we'll catch up soon.
It's been a pleasure, Alpesh, as always, and I appreciate everybody who attended. Again, I'd like to maybe come back in person sometime back to India. So we've been talking maybe about an event across India. So if it does happen, please follow the Twitter handle, and I'll make sure that you guys know about it.
Yeah, definitely. Sounds good.
All right. Thank you so much.
Thank you.
Have a great day.
Thank you. You too.
Bye-bye.
Cheers. Bye.